Least common multiple is very much like least common denominator. Least common multiple, also known as least common denominator. I'm going to do this long way. We don't have very big numbers, so it won't be as long as I'd like it to take. If I were to talk about multiples of 9, I could say 9 times 1, 9 times 2, 9 times 3, 9 times 4, and so on. I'm multiplying that number. 6, I could say 6 times 1, 6 times 2, 6 times 3. Oh, look at that. I made it. I have two numbers that this is the least, they're in common, and we've multiplied. This way works really well with little teeny numbers, but I promise you it does not work with big numbers because the numbers could get very large. I have one example I always use to show you how ridiculous this method would be for anything but small numbers. But since we did it, this is the long way. The answer is 18. Let me show you the way I really want you to learn it. I'm going to say 9. A factor tree means I find two numbers that multiply together to give me 9. And we don't ever use 1. I'm done because these are both prime. Prime means that the number is only divisible by itself and 1. For example, 3, well, 1 times 3. That's it. 2 is the only even prime number and also the smallest. We don't consider 1 a prime number. Any other even number is divisible by 2. It can't be prime, but 2 is the only even prime. We have 9, which is 3 times 3. And usually I say to circle them. When I do this with bigger numbers, I always say circle the prime numbers at the bottom because sometimes they get lost if you have a long tree, but we don't. 6 is really just going to be 2 times 3. This is the way I find a common denominator or a common multiple. And I'd like for you to try doing it this way. I'll show you why in a minute. When we start having to find common denominators for polynomials, which we will towards the end of this course, most of this stuff is a buildup so that you understand how fractions work, how to find common denominators. Those are things you need to do when you don't have just numbers. So this system really does work, I promise. And if you don't understand it, I'll do it 20 times if I need to. After I get my factors into prime numbers, what I need to do is make them the same in the smallest way possible. Isn't that what we just said above? Here, we had to make them the same in the smallest way possible. So we found 18. I want to make these numbers the same in the smallest way possible. Over here, notice, I have 2 3s, and I only have over here 1 3. They need to be the same. I'm going to multiply this by a 3. Now I have 2 3 3. Okay, that's good because I have 2 3s. I have 2 3s here, and I have 2 3s here. But then I look back and I say, oh, but something's missing from the 9 to make the numbers the same. If I put a 2 here, now both of them are 2 times 3 times 3. All you have to do is multiply 9 times 2, because we already know 3 times 3 is 9, and 6 times 3. And what does that equal? They both equal 18. The answer here is 18. Now, let me show you on a harder number. Let's do 49 and 63. Well, Would you like to multiply 1 times 49, 2 times 49, 3 times 49, 4 times 49, until we find a number where 1 times 63, 2 times 63, that sounds like a terrible idea to me. This is 3 times 3. So basically here we have 3 times 3 times 7, and here we have 7 times 7. And one thing we could always do is I can circle everything that's in common. Move the things that are not in common to the other position. I have 2 3s over there, and I don't have them over here, so I'm going to multiply this side, and I have another 7 over here that I'm going to move over to this side. These 2 3s are coming here, and this 7 is coming here. And now my least common denominator is going to be, this is 49 times 9, which is 81, 8, 36, 44, or 41. And I'm going to guarantee you, since this is going to be 3 times 3 and 7 times 7, it's going to be the same thing. But I'll do it. We have 63 times 7, which is 21, or 41. My least common denominator between these two numbers is 441.